Here is another question on motion of projectile. A batsman tries to hit six, but the ball is caught by a fielder on the boundary. The ball is in the air for 3 seconds and the fielder is 60 meters from the bat. Now, we are asked to calculate the horizontal component, the vertical component of the velocity with which the ball is hit. Hence, find the magnitude and direction of this velocity. Now, of course, when we look at the question, okay, we're given that a batsman tries to hit six. This does not mean that we are going to use the number what six in this question, but the ball is caught by a fielder on the boundary. So the ball is in the air. So which means now for the ball to be in the air, then that means the 3 seconds we are given here will be the time of flight. And the fielder is 60 meters from the bat. So which means that the horizontal distance, which is the range, will be 60 meters in this case. All right, so to be able to calculate the horizontal component of the velocity with which the ball is hit, let's do it this way. Um, let's do it this way. Now we are given time of flight. We're given the time of flight because the ball is in the air for 3 seconds. So which means the time of flight will be 3 seconds. Okay. Then also we are given the range, which is the distance 60 meters from the bat. So which means the range. Let's put the range as x, and that will be 60 meters. That's the range. So we are asked to calculate the horizontal component of the velocity with which the ball is hit. So which means to calculate the horizontal component, so we can say that Ux, okay, represents horizontal component, horizontal component of velocity. So we need to find horizontal component of velocity and also what? Vertical component of velocity. Vertical component of velocity. All right, so these two are not given. All right, so now to be able to calculate the horizontal component of velocity, now we can see that we are given the range, which is 60 meters, and the time of flight, which is what? 3 seconds. So which means now in this case, for the ball to remain in the air for 3 seconds, that means that the horizontal component of velocity remains constant throughout the flight. Okay, so in that case, so the first thing is to what? To calculate Ux. Now to calculate Ux, which is the horizontal component of velocity. So like I said, the horizontal component of the velocity will remain constant throughout the flight because here we have that the ball is in the air for 3 seconds and the fielder is 60 meters from the bat. So which means this is the range. So the range is what? X, which is the horizontal distance. Okay, and it travels this distance 3 seconds for 3 seconds. So that means the horizontal component of velocity, which is Ux, will be equals to the range over what? Time of flight. So what we have here is we have Ux equals to range over time of flight. Yes, that's what it means. Over time of flight. So which means Ux will be equals to the range. The range is 60. So that will be 60 divided by time 3 seconds. So that will be 3. Okay, so that Ux will be equals to 20 meters per second. So this is the horizontal component of the velocity. Now, that's A. Now we also want to calculate the vertical component of the velocity with which the ball is hit. So to be able to calculate the vertical component of the velocity, Yeah, we want to calculate the vertical components of the velocity. So the vertical component of the velocity is what? Uy. Okay. Now, but because we are given that the ball is in the air for 3 seconds, okay, and the fielder is 60 meters from the bat, so it means that in this case, we are going to make use of one of the equations of kinematics, to calculate Uy. Now, let's not forget that Uy is the vertical initial velocity. So the vertical velocity, the formula for vertical velocity, okay, so we're using Vy equals to Uy, okay. Now in this case, we're going to have gt, okay, where t is the time of flight. Now we know that the vertical component of the velocity in this case will be when we have the vertical velocity to be equals to 0, because at the highest point of the ball's trajectory, the value of Vy will be equals to 0. That will be at the highest point of the ball's trajectory. That is, the ball is in the air for 3 seconds. So that means at the highest point of the ball's trajectory, okay, the value of Vy will be equals to 0. So which means this will be equals to 0. That is, at the highest points of ball's trajectory. Okay, so this will be 0 equals to Uy minus gt. Now let's not forget that g is what? 9.81 meters per second square. Okay, now we just calculated time of flight. The time of flight, okay, we're given the time of flight to be 3 seconds. So which means Uy will be equals to gt. So that Uy will be equals to negative 9.8. Okay, this will be 9.81, okay, multiplied by 3. Yes, 9.81 multiplied by 3. Multiplied by 3. That will be 29.43. 29.43 meters per second. So this is Uy, which is the the vertical component of the velocity with which the ball is hit. Now, the last question is for us to find the magnitude and direction of this velocity. That is the velocity of projection. Okay, of course, because it is velocity of projection. So that means the magnitude of this velocity, okay, that's the velocity of projection, will be equals to the square root of the sum of the squares of the vertical component of velocity and the horizontal component of velocity. Okay, so let's make that C. Magnitude and direction of the velocity of projection. Velocity of projection, u equals to the square root of ux raised to the power of 2, then uy raised to the power of 2. So this is the magnitude, okay? Magnitude. So we have ux and this is uy. Why this is u? This is the y-axis, this is the x-axis. So this is the angle which represents the direction of the velocity. All right, so let's plug in the value of ux. That will be 20 raised to the power of 2. Then the value of uy, which is 29.43 raised to the power of 2. Okay, so what is 29.43 raised to the power of 2 added to 400? Okay, that will be 1266 points. So we have u to be equals to 1266.12. Okay, so let's get the square root of 1266.12. The square root of 1266.12. That will be So the velocity of projection is 35.58 meters per second. So the magnitude of this velocity, which is this, equals to 35.58 meters per second. That's it. Now let's calculate the angle. From here, this will be Uy. So the direction. Now let's calculate direction, which is theta. So we know that this is opposite and this is what? Adjacent. So we have tan theta to be Uy over what? Ux. Uy, okay, over Ux. So theta will be inverse tan of Uy divided by Ux. So let's plug in the value. So Uy is 29.43 divided by Ux, which is 20. Okay, 29.43 divided by 20, that's 20. That will be equals to, so we can say the inverse tan of 1.4715. Okay, so let's get the inverse tan of 1.4715. Okay, the inverse tan of 1.4715, that will be 55.8. So this will be 55.80. So this is the direction. So the magnitude and direction of the velocity, okay, is, so we have the velocity, which is 35, okay, 35.58 meters per second, and then the direction is 55.80 degrees. This is the final answer. The noblest pleasure is the joy of understanding. Bye bye.